Okay guys, today we're going to be learning about rational numbers. Make sure you have your notes set up as Cornell notes with the learning target and everything that's on the backboard. Alright, first thing are sets of numbers. Today we're only going to talk about rational numbers. Rational numbers are numbers that can be written as a ratio or fraction. So any number that can be turned into a fraction is considered a rational number. Inside of rational numbers we have something called integers. Integers are the set of positive and negative whole numbers. For example, -2, -1, 0, 1, and 2. Notice they do not have any decimals. Okay, an integer is just any number that does not have a decimal after it. Okay, inside of integers are whole numbers. Whole numbers are the set of positive whole numbers. So if you look at integers, it should say are the set of positive integers. Including 0. So if you look at integers, if we take away the negatives, then we have what they gave us for the whole numbers, 0, 1, 2, and 3. Okay, so whole numbers are never negative. Integers can be negative, but they cannot have a decimal. And then rational numbers are just any number that can be written as a fraction. So over here, we have some examples of rational numbers, integers, and whole numbers. Make sure you wrote those definitions down. Alright, to change a fraction to a decimal, it's fairly simple as long as you have a calculator. You're just going to divide the numerator by the denominator. Important, numerator is the number on top. Denominator is the number on the bottom. Okay, you've got to do it in that order. Numerator divided by denominator. Okay, there are two types of decimals. If the division ends with a remainder of 0, it is a terminating decimal. Now terminating, that means it ends. So if I have, for instance, a number like 5.25, that number ends after that 5. There's nothing else there. It would just be a bunch of zeros. So that's considered a terminating decimal. The other option is a repeating decimal. So if the division reveals a repeating pattern, then it's called a repeating decimal. This is something like 0.33333, on your calculator when it fills the whole thing up. We would write that as 0.3 with a bar above the 3 to show that it is repeating. Alright, so you need to know there are two different types, terminating and repeating, and you need to know what they look like. On the other hand, to change a decimal to a fraction, it kind of depends on which type of decimal we have. If we have a terminating decimal, then we're going to place the digits over the last place value and reduce the fraction. Okay, so by last place value, I mean the smallest place value. So if it's to the 10th place, I'm going to put it over 10. If I have a digit in the hundredths place, I'm going to write it over 100. In the thousandths place, I'm going to write it over 1,000. Then I'm going to simplify or reduce as much as possible. If I have a repeating decimal, I'm going to look for the pattern and set up an equation. And I'll go over how to set up an equation when we get to those examples. Alright, so these examples, writing a fraction or mixed number as a decimal. Make sure you write down all of these examples in your notes. Okay, so 3/4. In order to turn that into a decimal, I just punch in on my calculator 3 divided by 4, and it gives me 0.75. Okay, that would be my decimal. Now, most of you probably knew that 3/4 was the same thing as 0.75, but if you didn't, there you go. That's how you find it. Just divide it on your calculator. All right, 4 and 13/25. My 4 is just going to come down. So I'm going to leave that as 4. On my calculator, I'm going to do 13 divided by 25, and I get 0.52. So 4.52 is my decimal. All right, example C. If it's negative to start with, then we're going to leave it negative as our decimal as well. So I'm going to leave it as negative. 2 divided by 9 on my calculator is 0.222222. So I'm going to write that as 0.2 repeating. So that's what that repeating bar is for. It tells me it continues going. All right, same thing on D. I'm going to bring my 3 down. And then on my calculator, 1 divided by 11 is 0.09090909. So looking at that pattern, I see that I need 0, 9, and both of those are repeating. So I'm going to put my bar above both of them. Example E. In a recent season, NASCAR driver Jimmie Johnson won 6 of the 36 total races held. So I'm going to do 6 over 36, that's 6 out of 36. On my calculator, when I divide that, 6 divided by 36 is 0.16, and it repeats all the way to the end. Our directions say round to the nearest thousandth, so 0.167 would be the correct decimal there. All right, now we're going to go the other way. We're going to change each decimal to a fraction or mixed number. All right, so looking at F, like I said, same thing. If it starts as negative, then I'm going to leave it as negative. Now looking, negative 0.14. That's the same thing as 14 hundredths. So I'm going to write that as 14 over 100, since that 4 is in the hundredths place. Now I can simplify. Dividing by 2, I get negative 7 over 50. So negative 7 over 50 is going to be my answer. All right, moving on to example G. I'm going to leave my 8, like I said before. That right there would be 75 hundredths. So 75 over 100. I don't know why I put that dot there. All right, 75 over 100. I can reduce this by dividing by 25. So 8 3/4 would be my fraction, or my mixed number rather. All right, for H, looking at H, right there, that's in the tenths place. So that tells me I've got 7 tenths. Now if I can't reduce, then I'm going to leave that as my answer. So my answer is just 7 tenths. All right, and I, this one goes past the hundredths place. It goes to the thousandths place. So I've got 725 over 1,000. I can divide that by 25. When I divide by 25, I get 29 over 40, which cannot be reduced any farther. We get 29 over 40, which cannot be reduced any farther, and therefore that is your answer. All right, the next thing we have to look at is changing a repeating decimal to a fraction. Now that's a little bit more difficult. Okay, we're going to have to set up an equation. So looking at this, I have 0.4 repeating, which is 0.44444. Okay, so this is in the tenths place. Okay, it's repeating in the tenths place. Okay, so since it's in the tenths place, I'm going to multiply this by 10. So really what this looks like is 0.4444, so on. I'm going to multiply that by 10. When I do that, I get 4.44444, so 4.4 repeating. All right, so over here, I need to set up an equation. Since that repeating, the smallest place is in the tenths place, I'm going to put 10x. When I multiplied by 10, I got 4.4 repeating, so I'm going to write that on the right-hand side. Now, we're going to go back and let x equal what we started with. So let x equal 0.4 repeating. Now, on the left, I'm going to subtract x. On the right, I'm going to subtract what is equal to x. We just said that 0.4 repeating was equal to x. Now, you should know that in front of a variable, there's an imaginary 1, so I can fill in a 1 there. 10x minus 1x is 9x. 4.4 repeating minus the 0.4 repeating part just leaves me with 4. This is a one-step equation. To undo the multiplication, I divide. So I get x equals 4/9. Now, if I could simplify that, I would, but I can't simplify 4/9, so that's going to be my answer. Now, on your calculator, you can check yourself. 4 divided by 9, it does give you 0.4 repeating. All right, the next one, 0.256 repeating. Okay, now, our smallest repeating number is the 6, and it's in the thousandths place. So I'm going to multiply this by 1,000. When I do that, I get 256.256 repeating, because remember that 256 keeps going. 256, 256, 256. Okay, so I get 256 and then 0.256 repeating. Now we're going to set that equation up. 1,000x equals 256.256 repeating. Now going back, letting x equal what we started with, 0.256 repeating. I'm going to subtract x on the left-hand side again. On the right-hand side, instead of x, I'm going to subtract what it's equal to, the 256 repeating. So on the left, I get 999x. On the right, I get 256. Dividing by that 999, we're going to get x equals. And then let's see, we actually cannot simplify that. So 256 over 999 is my final answer. Now, if you do that on your calculator, you will see that you're going to get 0.256 repeating. Last example, 0.156. Now again, my smallest number that's repeating is the 6, and it is in the thousandths place. However, notice that it's not all repeating. So I've got 0.156, and then it's just going to be 6666666. So I'm going to multiply this by 1,000, and I'll get 156.6 repeating. So over here, setting up my equation, 1,000x equals 156.6 repeating. Now in this case, I don't want to just use x. I don't want to subtract 0.156 repeating. I need to move the decimal so that I just have that 6 repeating on the right-hand side. So to do that, I'm going to take x, which would be 0.156 repeating. If I move my decimal 2 times, that's the same as multiplying by 100. So 100x equals 15.6 repeating. All right, so now I'm going to subtract that 100x and subtract 15.6 repeating. Okay, since those are the same thing, I can do that. 1,000 minus 1,000x minus 100x is 900x. 156.6 minus 15.6 is going to be 141. And then the 0.6 is actually cancel. Dividing by 900, we're going to get that x equals 141 over 900. If you divide that on your calculator, you will see that you get 0.156 and the 6 continues. All right, right now I need for you to complete page 30, 1 through 13. You can either use your book or you can use the PDF that is on the website. When you finish, go show the sub. She will check it and mark your name off the list. Then begin on the homework assignment that is also written on the backboard. See you tomorrow.